Hello everyone, it's July 29th. Alright, let's get down to it. Longest subarray with maximum bitwise AND. Your given integer array, consider a non-empty subarray has the maximum possible bitwise AND. In other words, let k be the maximum value of the bitwise AND of any subarray of nums. Then only subarrays with a bitwise AND equal to k should be considered. Return the length of the longest such subarray. The bitwise AND. Okay. The longest bitwise AND. Now, bitwise AND is different, because or we can just go through everything and then we call it. AND is different. And if it's a 0, then we should not consider it. In the longest bitwise AND, as a subarray, the ones with the highest bit will triumph, right? The one with the highest bit will triumph. So, I don't know, maybe we need to list out. So, in this I have 1, 2, 3, 3, 2, 2, right? So I have basically 1, 1, 0, 1, 1, 1, 1, 1, 0, and a 1, 0. So I need the highest position. So highest position, so this one is eliminated, right? And then the second highest position. And so these gets eliminated. So now we have 2. So essentially, I can make 10 to the 6. Okay, 10 to the 6 is not even okay, do I have a log? One, two, three. Wait, 1, 2, 3, 4, 5, 6 divided by. Oh no. Divided by log 2. 19. 19. So 2 to the 19 is 1, 2, 3, 4, 5, 6. Yeah. And 2 to the 20 is more. So 19. So at the most is 19 bits. Right? So at most is 19 bits. So I can just set out 19 positions and then we go, the top position. We'll go through everybody and then see if anybody is set. Right? If we find those are set, we put it into an array. Right? We'll put the index in. So we have the first one, and the second one, and the third one. Right? Whatever. So we put it in. And then we need to decide if there's any subarray among them. Alright? Not necessarily. I think it's just we want to essentially, if two numbers are not the same, then one of them definitely has a bigger than the other one, right? one of them definitely have bigger than the other one. So yeah, I should just keep going, right? Keep going. So I see the second one. Anybody is has yeah. So we get the first. And not necessarily the largest number. Or is it? It is the largest number, right? It is the largest number. Because if you are not the largest number, then the largest number is bigger than you. And if you're not the largest number and you OR with somebody else, then you end with somebody else, then that's the biggest you can get, right? That's the biggest you can get. It's just yourself. You can never get bigger than yourself. That's bitwise AND. You can never get bigger than yourself, right? Therefore, the question turns into finding the maximum value and to see if there are multiple of them, right? What's the consecutive number of maximum values? So what we can do is we just keep going and then record the length, right? The length we have so far. And then if I have a new one, I just swap it. If not, I just, keep it. All right, keep it. If I have just the current, the length, the consecutive length of the largest number so far. Okay. Wait, are we solving this for the 30th? I think we got a date wrong. We're solving for 30th. Let's make this into 30. This should be 30. This is 30. Alright, so we're gonna write our reasoning. Two, 4, 1, 9. For bitwise AND, it is not possible to generate a larger value. Alright, it's not possible to generate a large, do it one more time. For bitwise AND over a subarray, it is not possible to generate a larger value than the smallest, right? Than the mean of the subarray. The mean of the subarray determines the overall bitwise AND, right? So it is not possible to generate a larger value than the mean of the subarray. Thus, the problem can be rephrased as finding the longest subarray that consists of the max value of nums. And that's it. So this we can solve by, we can say the max. Okay, yeah, let's just do it that way. Max value shall be, I remember we have a max element, nums.begin, nums.end, and we can call, I think we can do something like that. This is getting the max value. And int res is equal to 0. And for, actually res should be 1, right? For int I equal to, actually this should be max val equal to nums 0. And then it should be 1, I smaller than nums size, I plus plus. Okay. And then we say if nums I is equal to nums I minus 1 and nums I is equal to max val. So when that happens, then we say, what do we say? Res plus plus, right? Else, actually the else I don't reset res. I do. Okay, so hold a second. We actually need another one. Current. Ugh. Let's do this. Int current is equal to res. So this will be current plus plus. Current equal to 1. And then res will equal to maximum res on current. And if that's the case, yeah, that's fine. That's fine. All right. So we'll every time we check if it's equal, and this is equal to max value, then we'll update. Makes sense, right? Otherwise, if they are equal, they can be equal, but it's not the max, then that's actually not right. That is actually not right. Because if I have the max value show up the first time, oh, that's fine. Yeah. Then this will not be equal. Then we'll always set it to 1. I don't care. This is not equal. I set it to 1, and it has to be equal. And then both is this, and then we do this. Okay. Yeah, looks about right. Let's try and see how this one goes. All right, looks about right. Let's submit it. There we go. As expected. Alright, let's see. What's the tutorial? Longest, blah, 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 blah. What's the intuition? I think it needs to get to the intuition. The largest bitwise AND can only be achieved when all the elements in the are equal to the max number. Yes, that's the intuition. So the task is to find the longest subarray where all the elements are maximum. Exactly what we said, the longest subarray that consists of the max value. Implementation wise, I think they don't get this one first. I think they keep the two current streak. If it's smaller than this, I set this, I set this. If it's equal to, I do this. Otherwise, I do this. Yep, that's the same. This is a very funny meme, right? Alright, so that's that. We have some time, but yeah, I don't have the Ghana today. Anyway, let's just